In order for me to figure out number one, I need to go through and figure out what the oxidation state of each element is in the course of the reaction. So in iron oxide, I know the oxygen to be a -2 because that's one of my rules and that's its charge on the periodic table. And then I'm going to figure out what the charge of the iron is. When I figure that out, I figure it out to be +3. The way that I do that is I say I have 2 irons and I don't know its charge. I have 3 oxygens, and according to the periodic table, each oxygen has a charge of -2. And these must total to equal 0 because this compound is uncharged. Solving for x, I get a +3. The copper is alone and nothing is written on it. It's 0. The iron is alone and nothing is written on it. Within copper oxide, the oxygen's a -2. And then for the positive and negative to be balanced when they're put together, the copper must be a +2. To answer the questions, I'm going to look at what changed charge over the course of the reaction. The iron changed charge, the copper changed charge. Quite literally, the one that goes down in charge is the one that's reduced. So Fe went from +3 to 0. Literally, that's what reduce means, to get smaller. So we can say that's reduced. So when I answer this, I'm going to answer Fe, and I'm going to answer it with the charge that it has on the left-hand side of the reaction. What is oxidized then is the other one, which is Cu. The oxidizing agent and what is reduced go together. The difference is for the agent, we name the whole compound. The reducing agent and what is oxidized go together. Again, we name the whole compound, but in this case, it's the same thing. So our rules for number one, we always answer something from the left side. We show charges if relevant. In other words, if they're there. And then here, we use the whole compound as part of our answer,